Module 7, problem number 7. A doctor wanted to determine whether there is a relation between a male's age and his HDL, so-called good cholesterol. The doctor randomly selected 17 of his patients and determined their HDL cholesterol. The data obtained by the doctor is in the data table below. Complete parts A through F below. Part A. Draw a scatter diagram of the data treating age as the explanatory variable. What type of relation, if any, appears to exist between age and HDL cholesterol? So when we read here that age is the explanatory variable, that's the predictor or the X variable. So let's go ahead and open our data set and then click on the icon to open it in StatCrunch. Go to Graph, Scatter Plot, and we said that age is our X, which is handy that they named the variable that, and then click Compute. And we see here there's no real discernible pattern. It's kind of scattered all over the place. So let's go back to our question. So it says, what type of relation, if any, appears to exist between age and HDL cholesterol? There does not appear to be any relation. The other options say the relation appears to be nonlinear or there appears to be a linear relationship. Remember, linear would be if we were to see, say, like a straight line this way or a straight line this way. See the data group kind of like that. Or maybe nonlinear. Maybe you see a curve down or maybe a curve up. Those are some of the very common nonlinear shapes. We don't see any of that, so there does not appear to be a relation. Nice work. All right, part B, determine the least square regression equation from the sample data. Let's go back over here. We're going to go to Stat, Regression, Simple Linear. Again, we're going to select age as our explanatory variable and HDL cholesterol as our response variable. And we're just going to click Compute to find our linear regression equation. Here we go, let's do this so we can see them both at the same time, make our life a little easier. Here we go. So we have here our slope is right here, our slope estimate. So it says round to 3 decimal places, that's negative 0.118. And our intercept is right here. You can also see it right here in the equation or down here at the estimate. So that's going to be 49.889. Once we round to 3, check answer. Excellent. All right, are there any outliers or influential observations? So when you're looking at the scatter plot and you're looking for outliers, do any of these really totally deviate from the overall pattern of the data? Well, in part A, we said there really is no overall pattern of the data. There's no overall pattern. Right? In this case, we don't see any outliers. So no, there are no outliers. Excellent. All right, what are the null and all, part D. Assuming the residuals are normally distributed, test whether a linear relation exists between age and HDL cholesterol levels at the alpha equals 0.01 level of significance. All right, I'm going to go to the lesson this week, and I'm a big fan of these purple tables. For me, they're really easy to follow and a really good reference tool. I recommend these to kind of have this handy for the final as a good reference tool. So in this case, we want to determine if a linear relation exists between age and HDL cholesterol. In that case, we're saying, does the slope equal 0 or does it not equal 0? If the slope doesn't equal 0, we would say that there is a linear relationship. So when we're saying that it does not equal, that's a two-tailed test. That means our alternative hypothesis is that the slope is not equal to 0. Remember, the slope is the sign of the correlation. If you have a really high slope close to 1, either positive or negative, that would tell you that there's a high or a very strong linear correlation. So as we see here, our only option is that the slope is not equal to 0. So final check. Excellent. Use technology to compute the p-value. Use the Tech Help button for further assistance. So the p-value, we're going to go back to our StatCrunch window and close out our scatter plot. We're going to actually go back to this. Just to reiterate, let's pretend like we didn't just do that. We'll go back. We're going to go to regression, simple linear, just like we did to create the linear regression. So if you know you're going to have to do a couple like these, you can go ahead and set them up the way you want them. In this case, the default is hypothesis test and that the intercept does not equal zero, that the slope does not equal 0 right here. It automatically sets it up for both the slope and the intercept. You don't need to change anything if you're just testing to see if there's a linear relation. So we'll get the same results we just saw a few minutes ago, but I just want to make sure it was clear how to set that up, that we didn't just get there from nowhere. So when we go down here and we scroll over, we see our p-value. So we're going to put that in. We're looking for the slope. Remember, we're trying to see if there's a linear relationship. That means we're looking at the p-value of the slope. So in this case, we have to round to 3 decimal places. That's going to be 0.559. Check answer. Good job. All right. What conclusion can be drawn at the alpha equals 0.01 level of significance? Well, let's go back to our thing here. From all of our hypothesis testing, we know that if the p-value is less than alpha, we reject the null hypothesis. So going back here, our p-value is 0.559 and our alpha is 0.01, which is much bigger than our alpha. Our p-value is much bigger than our alpha. So in that case, we do not reject the null hypothesis because, so we know right now, do not reject the null hypothesis because the p-value is greater than alpha. So that's option C. Check answer. Excellent. All right, assuming the residuals are normally distributed, construct a 95% confidence interval about the slope of the true least squares regression line. So again, we're going to go back to our StatCrunch window, back and forth. All right, again, we're going to do it the same way we did before, but now we're going to be checking confidence interval instead of hypothesis test, just like we did a couple of modules ago when we first covered hypothesis testing and confidence intervals. So we're going to go down to regression, simple linear again. We're going to select our X and our Y variables, and we're going to scroll down to check confidence intervals. Remember last time we just looked at hypothesis test being the default. So we're going to click here. We're doing a 95% confidence interval, which is already input, so we don't have to change anything. Click compute. Now, we see a couple of upper and lower limits, right? Not just one. Well, we wanted to find our confidence interval about the slope. So we're going to go over here to slope and see these are our upper and lower limits, those smaller numbers there. So our lower bound, rounding to 3 decimal places, is negative 0.541 from right here. And then our upper limit's going to be right here, 0.304, once we round that. 0.304. All right, check answer. Nice work. All right, for a 42-year-old male patient who visits the doctor's office would using the least squares regression line obtained in Part B to predict the HDL cholesterol of his patient be recommended. It says here, if the null hypothesis was rejected, that means that this least squares regression line can accurately predict HDL cholesterol of the patient. If the null hypothesis was not rejected, that means the least squares regression line cannot accurately predict the HDL cholesterol of a patient. So let's click continue. And just to make sure that's clear, what we're saying is if the slope is 0, then there's no linear relationship. So that means it's not really a good model. If the slope's not 0, then yeah, there's probably a good linear relationship and the model's a good prediction. So in this case, remember from up here, we did not reject the null hypothesis. We basically said that the slope is 0 or very close to 0. So should this least squares regression line be used to predict the patient's HDL cholesterol? Choose the correct answer below. No, because we did not reject the null hypothesis. We said that that slope or that correlation is close to 0. Well done. All right, good estimate for the HDL cholesterol of this patient is. So one of the things that the text talks about is using the mean of your Y variable, your response variable, as a prediction. It's not the most accurate prediction, but if you have no other means to make a prediction, it's not the worst option in the world. Of course, in the real world, we would do a little bit more analysis or find other things that fit a regression model better. But in this kind of situation, the mean is an acceptable way to make the best prediction you can. So let's go back to our StatCrunch window. We're going to go to data, or excuse me, stat, summary stats, column. Remember way back in the beginning of the class when we found the mean of our variables. We're going to click on Y, our HDL cholesterol, and mean, because all we care about is finding the mean in this case. And as you see here, it's 44 point, what do we need, 2 decimal places? That's 44.53. Let's plug that in. Check answer. Well done. So that's how you do problem number 7. If you have any questions, let me know.